So we can use Pythagorean theorem to help us determine what kind of triangle we have. Is it acute, is it obtuse, or is it right? So obviously, if it's a right triangle, c squared should be equal to a squared plus b squared. That makes sense. So if we take this right triangle and just shift this side B in a little bit to create an acute triangle. So if we keep keep B and A the same, but make that angle smaller. Remember we learned that the larger the angle, the bigger the opposite side. So if B and A are going to be congruent, if B in this right triangle is going to be congruent to B in the second triangle, and A in this right triangle is going to be congruent to A in the second triangle, and all we do is change this angle from being a right angle to an acute angle, we've just made that angle smaller. So therefore, we're going to make this opposite side smaller as well. So if in this triangle, c squared is going to be equal to b squared plus a squared, well, we just made c smaller in this acute triangle because we made that angle smaller. So that means that c squared is going to be less than a squared plus b squared. And then vice versa. And if we had taken this angle, this right angle, and swung it out, instead of making it smaller, if we made it an obtuse angle, if we made it bigger, like so, keeping B and A the same lengths. I didn't actually make B and A the same, but you get the gist. And we make that angle bigger. So now we've made that angle bigger, so we're going to make side C bigger. So here, c squared was equal to a squared plus b squared. Now that c is bigger, c squared is going to be greater than a squared plus b squared. Because this is an obtuse angle. This is an obtuse triangle. So the moral of the story is we can plug the biggest side in for C and then plug the other two sides in for A and B. And if c squared ends up being equal to a squared plus b squared, it's a right triangle. If c squared is less than a squared plus b squared, it's an acute triangle. And if c squared is greater than a squared plus b squared, it's a obtuse triangle. So always put c squared on the left. Always put c squared on the left and a squared plus b squared on the right. So let's test this out. Determine if the following sides represent an acute triangle, an obtuse triangle, or a right triangle. So I'm going to put C, my biggest side, on the left, c squared, and I'm going to compare it to 5 squared plus 6 squared. Well, 7 squared is 49. 7 times 7 is 49. 5 squared is 25. 6 squared is 36. And if I add 25 and 36, I get 61. So c squared is less than a squared plus b squared, making this an acute triangle. So since c squared was less than a squared plus b squared, it's acute. Now I'm going to test out the second triangle, 5, 10, and 14. I'm going to compare 14 squared with 5 squared plus 10 squared. 14 squared is 196. And 5 squared is 25. 10 squared is 100. And so 196 is obviously greater than 125. So since c squared is greater than a squared plus b squared, it's obtuse. And then finally, I'm going to compare 37 squared with 12 squared plus 35 squared. 37 squared is 1,369. 12 squared is 144. And 35 squared is 1,225. And then when you combine those, you get 1,369. So they're equal, which means if c squared is equal to a squared plus b squared, this is a right triangle.